see it?
Yes.
All right. Unity. So first, what I'll do today is I'll talk about the interface. Unity is a game engine, obviously, as you all know, but you can do everything, anything that's audio, visual, and sound and interactive with it. So it's really easy to build anything that can run on a computer on Unity. Okay. But what I'll do is I'll go through the layout, all these small windows that you see here. I'll tell you how to build basic things, the basic things that you need to know in Unity to attach scripts and to visual objects and make them interact and react. And then go through what's called the UI. So basically interfacing with buttons, sliders, and stuff like that. And finally, on the second part, we can take a break in between, just go really quickly through other things that you can do in Unity. So this first part, when I talk about the interface and then the UI system, I'll go slowly. And then when I jump to the second part, I'll just like go fast through many other things that you can do. Sometimes just showing videos of what I found that you can do, and sometimes just like doing like real-time tutorials on it, okay? So first things first, when you open Unity, actually when you open Unity, you will probably see it like this. I always use a different layout, which is like this. It doesn't really matter, but what matters is to know what each of these windows is, okay? So we have the scene tab up here. This is everything that's gonna be in your world or level. Everything that you put in here can be in your level. We have the game tab here. This is what the app will see. So when you run the app, this is what you're gonna see. The project tab here is where you have all the files, everything that can be in your game. And then the hierarchy is everything that's on your scene. So when you open, you always start with these two elements here. A camera and a light. The camera is the most essential one. The camera is what actually determines what you see in the game. So if I add a cube here, we see it here because the camera is looking at it, as you can see right there, okay? If I move the camera, then the game view changes, yeah? So think of it as the camera as a kind of like a director of the movie. You just like put the camera wherever you want and then shoot the scene. And think of the scene as the set where you put all the objects that you want to be in that scene, okay? You can put everything in there. The light, this is the default light that comes with it. It's called directional light. This is just like a simulation of the sun, essentially. So even though the gizmo that you see here on the scene is just like these rays, it really illuminates the scene like from everywhere in this direction. But you can change the orientation of this. And then the lighting changes, okay? So again, scene, everything that you want to have on your application. Game, what you see at each moment, which can be everything that you have or not, depends on where you put the camera. Project, all the files that you want to use. So for instance, here you can see that I downloaded the Fab Academy logo, which I'm gonna use in a second. And hierarchy is where you have the things that are on the scene, okay? So hierarchy and scene are like highly linked. Then we have this one here, Inspector, which is where you see all the properties of every single object that you have on the scene. So if I click on camera, for instance, you can see this thing populates with all the properties of the camera. If I click on light, then I have all the properties on the light, okay? There's one extra window that I always put, which I think it's really useful. So here in the window menu, it's kind of like Photoshop. You can toggle on and off many different windows. These are the basic ones. I always add this one called console, and attach it down here. This is where you're gonna see all the error messages and debug messages that you have on your game or application. So I always have it here on this side. All right, so most important concept is like every single object that you have in Unity is called a game object, okay? So these two guys, even though they have different functionalities, they're both game objects. And every time that I put a 3D object in there, it's a game object. Everything is a game object. And game objects always have in common this tab up here on the top right, which is called transform. This is what determines where they are, what the rotation they have, and what the scale, okay? So this is common for everyone. If I take the cylinder and I change the scale, it just changes, yeah? If I change the rotation, it just rotates. Okay, this is common. And then depending on what object you have, then you have what's called components, okay? So this cylinder is a mesh, so it has mesh components. It has a mesh filter and a mesh renderer. Mesh renderer has different properties like lighting, if it casts shadows or not, if it receives shadows, what material is it using, if it has a collider, which is physics, we're gonna see this later on. The light has other...
I have a question. So, for example, if you have the cylinder has inside by default some components of, in this case, mesh, and you can enter the mesh and modify it, I guess.
Yeah, if you wanted to. I mean, even though it's called cylinder, because I created it like this.
Yeah.
And then I'll go through this in a second. You can go to cylinder and edit the mesh and then change it for a key.
Okay.
So you can change everything in here. If I say like do not receive shadows or do not cast shadows, that's gonna happen too. So for instance, yeah, I was gonna say like the light has different parameters, like the color of the light. If it creates shadows, what kind of shadows? And the camera has different properties too. Like one that's really interesting is if it's a perspective on an orthographic camera. Orthographic cameras are used for 2D games or 2D interfaces. Perspective cameras are used for 3D games or 3D interfaces. You can see the difference, right? You can change the field of view here, and so on. All right, you can use materials. I will cover materials later on the second part, but really quickly, when you create a material here on your project, yeah, I'm gonna see create material and call it my material. You by default, you create like this material that's called standard. And this is pretty much valid for most of the things that you will want to do. If you have a texture, you can assign it to this albedo box here. So I'm going to put the logo there. And then you have a preview here. And then we have the Fab Academy logo, okay? So once you have a material, you have a cube. One of the properties of the mesh is the material. So if I want to change it, I just go to this guy, my material, I can drag and drop it there. And now we have the Fab Academy cube there, okay? You can also just like drag and drop it up here to this guy, and Unity knows that because you're dropping a material into a mesh object, it has to go into the material field. Or you can even, if we create another guy, you can even drop it like right there. Oh, let me move the sphere because it's overlapping. You can even drop it right there on top of it. Yeah. remember that when you have a lit scene, the lighting affects how you see the materials, right? So now we have this like yellowish color. If we want to see the materials as they are, we need like a white light. And then the orientation matters too, and how we want to see them. Yeah. So these are the basic of the game objects. Like the most important thing is to know is everything is a game object, every single element on the scene. And every game object has a transform, all of them. And every game object, depending on what kind it is, it has different properties in the hierarchy, okay? Unity, as you saw, has several primitives here in the 3D, like a plane, cylinder, capsule, sphere, cube. You have to the objects tool, sprite, hexagonal sprite. If you want stuff that's not here, you can create it on Blender, download it anywhere. Any 3D file that you can find, like OBJs, FBXs, even if you have Blender, you can import .blenders. Anything is valid in Unity. So previously I downloaded this spaceship that I found online. And if you have like the OBJ, you just like drag and drop it on the scene. Now it's really big. We're gonna scale it down. And there it is. There we go. Okay. So as you can see, like any different mesh or object that you find online, any character, any mountain tree, anything, you can just like drag and drop it into here and then put it on your scene. And then it becomes another game object. So we have the transform and then in this case, the mesh render and the materials, okay? Right now, we're not seeing much because the light is not hitting it, but there we go. So when different materials have different properties, I'll cover the materials later on. There are different kinds of lights too. So as I said before, like the directional light simulates the kind of the sun, like an omnipresent light in one direction, but you can add different lights from here. I'm right clicking, by the way, to do this, right clicking on hierarchy. Then I can add a point light. I'll try to move it so that it's somewhere there. And then if we change the color to red, we're gonna see it. Can increase the intensity, right? So now I have like a point light, which means like this yellow sphere that you see is everything inside the sphere will receive light. And it will receive more light when it's like close to it or less when it's like farther away from it, right? Okay. Let's see the basics of how we can program stuff. We still have these, this cube. There we go. We still have this cube. I'm just gonna move the camera a little bit so that we're slightly closer to it, maybe. Now, imagine we want to do something with it, right? Which is the fun in Unity. For that, you use what's called scripts. So the way you program stuff in Unity is you create small scripts, but they can be small or not, but you create scripts and then attach these scripts to game objects to give them a functionality, an interaction, or something. So we'll start with a really easy one. We'll call it rotate. Okay. The language, as most of you know, is C#, which is like similar to Java or Python, actually. You can also program in many IDEs. I use Visual Studio because it comes with Unity. It all installs with Unity. It's highly interlinked with it. So when it comes to like suggesting types and highlighting errors, it's really convenient. But you can actually program in Notepad if you want. And then you save the file. You go back to Unity. Every time you go back to Unity, it will compile the file and let you know if there are any errors or not. So these are the basics of scripts. And this should be familiar to you all because it's exactly how the Arduino or open frameworks works. It has like a start method, which is the setup method in Arduino, and then an update method, which is the loop method in Arduino. So start, like setup, happens once at the beginning, and then update, like loop, happens constantly, okay? So to see that and see how it works, what I'm gonna do is, first of all, type this, debug.log. This is gonna print something on that console window that I have on the bottom right. And I'm gonna say start. And then in the update loop, I'm gonna say, just so that you can see it, print is an alias of debug.log, which is shortened and easier, okay? And I'm gonna say update. Save, go back to Unity. Now we have this script here. If I hit play, by the way, this here is, sorry, I moved the window. These three buttons here are what you use to test your game before you build it. So if I hit play, it will run every script. It will simulate all the physics. Everything will happen. So nothing's gonna happen now because I have not attached this script to anything. This script is in my project, but it's not in any game object. So it's not being executed. If I want to execute it, I can just like grab it, drop it, for instance, on the cube. And now if I hit play, we're gonna see like plenty of stuff there, okay? And as you can see, like the very first message was the start one, and then we have like plenty of updates infinitely. I call this script rotate because I wanted to rotate this object, okay? So how do I rotate it? First of all, I have to access the component of this object that allows me to rotate it, which is obviously the transform. And then I'll do something like this, transform.rotate. And then here, there's like many different options that you can use. I think the easiest one is to say that I want to rotate it on the vertical axis, and then by 5 degrees. Okay. What this will do is like on every update call, it will grab the object that this script is attached to and rotate it 5 degrees in the Y component. So go back here. This script is attached already. It's right there. If I hit play, this guy will start rotating, okay? Now, say I want to create a duplicate of this guy. If I do Control D, I duplicate object, okay? So I'm gonna make 2 copies of it and move them on the x-axis. Because I made copies of it, all of these game objects also have the rotate script there. All right, so if I hit play, this rotate script will execute 3 times on each object, and then all of them are gonna rotate. One of the coolest things of Unity, like a really, really essential thing, is that you can declare what's called public variables inside the class. And you do that here. Everything that you do before the methods are variables or members of the class. And if you declare a public variable, in this case, for instance, like a floating point number, which we'll call speed. When you do that, you go back to the interface, you'll see that now the scripts have the speed parameter that we just defined right here, okay? So what I'm gonna do is like, instead of rotating it 5 degrees, I'm gonna rotate it speed degrees. Okay. If I run it now, nothing will happen because all of the parameters are 0. Yeah. But if I go cube by cube and change these to random number, now all of them are going to rotate at different speeds. All right. So this concept of declaring variables and assigning numbers, it's really, really basic, and you end up doing all the time in Unity. The coolest thing is that you can change these parameters in real time. So if I go to this cube and I don't like the speed that it's rotating, I can just like change it until I find the right amount. Okay. You can change it live. One thing to take into account, which is like a mistake that we all, Unity programmers do, and obviously people who start working with it do all the time, is that when you change parameters while you are playing, when you stop playing, those parameters revert to the values that you had before playing. So changing parameters during runtime is only valid to know how you want your object to rotate. Once you know it, you just have to copy the number, stop, and then change the number for the value that you found that works for you, okay? You can do this way, or you can do this in another way, which is really similar, and I'll show you another important concept of Unity. I'm gonna remove all these scripts, okay? So all these cubes don't have a script now. And what I'll do is create a new object here in the scene that's empty. So this has nothing, only has a transform, has nothing else, you cannot see it or anything. And I will assign the rotate script to it, okay? Now, if I run it, this empty game object will rotate, but obviously we're not gonna see anything. You can see the rotation here on the Y. You're not gonna see anything. What I want to do is like this object, I want to make it rotate the 3 cubes that it has. Okay, so first of all, I'm just going to rename it to, I don't know, rotator. And I'll change my script now so that besides this speed, I want to access 3 game objects, cube 1, cube 2, and cube 3. Okay? And I go back to Unity. Now, this rotator script has these 3 objects that I defined that are, as you can see here, type game object, okay? So when I assigned these guys, what I have now is that inside my script, I have a reference with these 3 variables. I have a reference to these 3 objects here outside of my script, and I can do anything I want with them. So what I would do is exactly that. I'm just gonna call the rotate function on each of these 3 game objects, okay? And change the speed. Whoop. So again, what this will do is like grab these 3 objects, and for each of them, call the rotate function on their transform. And these 3 objects are my 3 cubes that I drag and dropped here, okay? So this is really important. Sometimes it's convenient to attach scripts to to each object. Sometimes it's convenient to have like a controller script that controls all the other objects. It really depends. All right. One cool thing is that if you need stuff to put on your game, you can create it yourself, obviously. If you can create sounds, you can create 3D if you know how to. If you don't, there's something called the asset store, which is where people put stuff that they've done for others to use. Most of the times you have to pay, but a lot of times you don't have to. And they're free to use. So this is how I found the spaceship before. If I type spaceship here, and there's like plenty of results. If you go here, price 0 because we're cheap. There's like plenty of spaceships for free that you can download, okay? And you click on any of them, you can see usually some screenshots, sometimes some videos of how they look like. Comments and stuff, how big they are, it's important. And sometimes people put stuff that's like 2 gigas for one element, it's not worth it. And if you like it, you just download it and then import it, and then you will appear here on your project, as I did with this guy. And then you just like drag and drop it to your scene, and there it is. Okay. All right. One cool thing about Unity that I mentioned is that once you have a project like this, you can build for many, many platforms. If you go to File, Build Settings, you'll see that now we have an Android project because I want to build it in my phone, but we could switch it to PC, Mac, or Linux, depending on what system you are in. We could switch it to iOS if you have a Mac. I have no idea what this is. This is like for Windows Store stuff, it's crap. tvOS, no idea, but PS4, Xbox One, or even WebGL, which produces like an HTML file and some other files that you upload to an FTP, and then you just go through your browser and you see exactly what you see on your game. So all of this with like a simple click, and then remember always to click this button here, switch platform, and then we'll switch all the elements to that platform. Since I have Android now because I want to build it on my phone, we'll do that in a second. What I'll do now is like I want to create a UI, okay? Since this week's lecture was about interfaces, and both Josep and Edu showed how to build interfaces in their programs, in processing, and what was the other? App Inventor, right? Unity has, I would say, like, it's not great, but it's very convenient UI system. And to do that, again, you can just right click here, and then you see this UI category right there with like all the objects. You can also go here, game object, UI, it's just exactly the same, okay? So all of these come like pre-configured for you. You don't really have to do almost anything. If I add a text there, and I move it, and I change the color because we don't see it. It's right there. What's important to know about UI elements on Unity is that they're always in front of the camera in a 2D plane, okay? So if I grab my camera now and rotate it, you'll see that this new text doesn't move at all because it's like embedded in the camera. It's always there because it's meant for that. It's like, if you remember, think of any game that you play that has an interface like a health bar or something like that. You move through the world, but the bars stay where they are, right? So this is the idea with the UI systems. So yeah, we can have like a basic text. You can type anything you want. You can change the font because Unity only comes with the Arial one, which is really ugly. I'm gonna try to put something else in there. Let's see. Yeah, so I just drag and dropped a font from Windows. And in here, again, text, as always, is a game object, and it has the components of a text, and one of the properties is the font. So I just change the font. We can make it bigger, not so big. This is a bit tricky. So this is the text component inside the whole UI that I have, right? So I can move it anywhere I want. It has some like guides here that you can attach to align stuff. It comes in handy usually. It's like the classic where you want to align it inside this. and other UI things, button. So obviously the text is not interactive at all, right? It's just like a label. If we want to do something, we need, for instance, like a button. So when you create a button, you see this, and you see that it has like this arrow here. It means that it has something inside. So it has a button and a text. The text of the button is obviously what you see there. So you can change it there. You can also change, oh God, come on. You can also change the font size and everything. Okay. Move it around. A button, like many other UI elements, you'll see has like an image component which determines how it looks. So like the basic thing is obviously the color. You can change the background color of the button. But you can also, if you have an image that you want to use as a button, you can just like drag and drop it here, source image, and then you will use that. By default, it uses the this UI sprite, which is, you know, anything you need. But if we do that, I don't know, it'll change it to that, which looks awful. So I'm just going to use this one. But you can drag and drop any image that you create or you have, and this way you can skin your interfaces any way you want. All right. This is the most important thing of UI elements here. It's called the events section or something. In this case, as you can see, it has like the on-click event, which is what you would expect for a button, right? It says like list is empty. So we're gonna add a click event to this button. And now we have an event. So something that will happen when we click it. Right now it says like none and no function. In order for us to program on the button, we need to create a script, attach it somewhere, and then drag the object that has that script in here and choose what function we want to call when we click it. I'm just gonna create a new object, an empty one. I'm gonna call it UI control, okay? And I will create a new script. I'm gonna call it UI control 2. So in this script, I will create a function called button click, which for now will only print something on the console. Okay. I do not care about these two guys, the start and update method, because I'm not gonna do anything right now on them. So I'm just gonna get rid of them. All right, so now we have this script here that has a function called click that does something, and we want to attach it to the button, okay? In order to do that, as I said, like when you have this event here, you need to drag and drop something that has the script that you want. We created this object for that purpose, and now we just need to attach the script that I created to this object, okay? So one is the object, the other is the script that we created. Now we have the object with the script. And now we can go to the button and say, okay, when you click me, access this object, and of this object, call this function, we need to make it public so that it can be seen from everywhere else. This is similar to Java and any other OOP languages. Honestly, you can have like private or protected methods. If they're private, you can only call them from inside, from within the class. If they're public, you can call them from anywhere. If in doubt and you're starting with Unity, I would say like make everything public and then you'll have no issues. Obviously, it's not the way to go, but to start, it's convenient. Okay, so now we're gonna go here and button click is there. Okay. So now what we have is like on the click of this button, we're going to access this object, and of this script, we're going to call the button click function. So we hit play and click this. We're going to see these guys here. Yeah. All right. Imagine you want to do something else, like we're gonna hide the 3 cubes, for instance. What would we do? First of all, get access to the 3 cubes by creating references to 3 game objects. Okay. And then what I'm gonna do is on each of these objects, I call this function set active. What this does is disables the game object completely. It's like doing this here. For any game object that you have on your game, this top left checkbox is like the disable or enable. So what I'll do here is set that to false. Okay. What happened? This error is really common, an assigned reference exception. I assigned these 3 game objects, I told them what to do, but I did not drag and drop them here. So this script doesn't know which objects it has to apply that thing to. So in order to do that, I just have to drag and drop these guys here. Well, it doesn't really matter the order. All right. Another UI element that I want to show you, you see there's like many, like a toggle, a scroll bar, drop down, input fields to enter text. I really want to show you the slider. I just think it's interesting. And it comes with like this default look and feel, which is fine for now. But you'll see it has like many things inside, which is interesting. For instance, like the background color is like this gray color here. We can change it to anything. The fill area is the color on the left of the handle. You'll see it in a second, it'll make sense. If I change the fill color to any blue, for instance, and I move the handle or the value of the handle, that's the fill area, and this is the background color. Okay. You can, again, like these are all objects that you can change. So if we change the graphic on the knob for something else, it'll change it to a square. Yeah. You could put, I don't know, like an emoji here if you want it, anything that you want. Interesting on the slide that is the event is a bit different. It's called on value change. So when you change the value of the slider, in this case, this event will be called. Every time that you move this slider slightly, this is gonna be called, okay? So I'm just gonna add something here. And I wanted to show you this case because it's a bit different than the button click. Because we're changing a value, but we don't know what value we're changing or by how much, right? So in order to capture these type of events on the UI, what you need to do is have a function that receives as a parameter a floating number, which is going to be the number of the slider that you move. So if we print this number when we change it, and we go to the event, attach our control object, and we call the slider function there. I think, this is not what I was supposed to do.
Maybe in the runtime, the control slider, that is the argument. So you have to send a value from the inspector. I don't know.
Say that again.
I see on value change, single, runtime only, UE control slider. And I see that there is a 0 there.
Yeah, I don't know this value here.
That should be the value, I guess.
That, I mean, that's the value that I, okay. Let me see. There we go. Sorry, I dragged the wrap component. So here you see, like in the console, as soon as I move the slider, it just gives me the value. It's from 0 to 1 because we specified it like this. Okay, in here you can see like mean value 0, max value 1. You can do anything you want from it, and then it'll just like remap all the gradient in between. Okay. You can force whole numbers, and then you're only going to get integers. Yeah. All right, I'll just like default it to 0 to 1. So yeah, this is pretty much like how UI works in Unity. You just like add UI elements. Each of them has its own thing and its own type of event, although these two types of events are the most common. And then you can just like change the colors, change the fonts, change the images as much as you want. And the next thing that I want to do is to put it on my phone. Okay, since I have an Android phone, I already have this set to Android, and I want to put it like in like a vertical layout. Okay, so as you see here in this small drop down here, you can sort of change the layout of the game scene to simulate what you want to see. If I do this, it's going to look like crap. Why? Because we've been doing this free aspect, not taking into account any constraints of how the screen would be or anything. So now that we are, if I do like, this is the resolution of my phone, for instance, it just like tries to do as much as well as it can to show everything. So what I'll do now is just, maybe I'll just like move these 3 cubes down there. I want to keep them, why not? And then I will keep that button as well. I'll move it down here and I'll make it much bigger. Increase the font size a little bit. There we go. I'll get rid of that text because it's useless. And then I will keep this slider. And I'll make it much bigger too. Like that. Centered. Okay. So, and once you see this in this like aspect ratio, the app on your phone should look exactly like that. So what I'm gonna do is just like build. File, sorry, I'm gonna do that again. It's like file, build settings. If you have like a somewhat modern phone, mine is 7 years old, so it's really not convenient to do stuff with this. But once you plug your phone in, there's a good chance it would appear here in run device. And then you can just do build and run, and it will like launch the app directly in your phone. Because mine doesn't do that. I'll just like click build instead. And what I'll do is like create an APK file. I'll just put it here, call it test. And then the only thing you have to do is access the file system from your phone and copy that file in. going to start opening here the phone. I usually put it inside documents. So once this is done, which will be in here. No. It always takes a bit to compile in Unity, honestly, and it's not the most efficient language. You'll see that if you create like an empty project with nothing on the scene and you build an executable file, it'll be like 30 megabytes or something like that, for whatever reason. So now I have the test file. I'm just gonna drag and drop it here.
Does the file get bigger if you add way more stuff, or would it stay? Yeah, so 30 is like the minimum, and then it gets more.
You can try. I mean, look at this. Maybe not 30. That this only like with like a button and 3 cubes, it's like 17 megabytes, right? So I would say it's like normal because Unity is not meant to do these kind of projects so simple, right? The executable files when you do like normal stuff are not that bad, meaning that you can have like a decent looking game for 200 megabytes, stuff like that. But when you start putting stuff on your project, the project on your hard drive, can get really, really big. So you have to be careful with that. Usually sometimes you just like download something on the asset store and you use 10% of it, but you keep everything else on your hard drive. So the project can grow. Okay, so now I have that that file in here. I'm gonna try to show you. This is the test. Down here it says install. It's open. And there we go. Okay. I can move these. I made the slider really small. I can move the slider or hide the buttons. Okay. If you want to do the same with iOS, again, you would need first a Mac. Then when you hit build on an iOS project, it creates the Xcode project, and then you open the Xcode project. And then if you have a license, a Mac developer license, then you can build on your iPhone or your iPad. So it's much harder. All right. Let's do let's interface with the Arduino now. I have this guy here. Let me see if I can put it in front of the camera. This is a speaker that I scavenged from an old PC, and I have one pin connected to the ground and the other to like this open cable that I'll plug into one of the pins in the Arduino. So what I'll do is I'll take part of the project that I did for input devices and part of the project that I did for output, I think. I'll put them together. Actually, we did that already, but I'll show you in a second. What the Arduino code does, what I want to do is to send the values of this slider through OSC via Wi-Fi, and then capture them on the Arduino, and then change the sound of the speaker. Okay, that's what I want to do. So before I go into the OSC code on Unity, I want to show you the Arduino code, which is really easy. It's similar to what Edu showed the other day. You have like the Wi-Fi configuration here with my password and everything open for you. This is the IP that I'm going to set my Arduino to. 10.00.20. This is the port that I will be listening to, 8500, okay? All of this here is PWM stuff to control the speaker that I did. So basically what you do is like say what frequency you want and what volume. And this is the important part. This is just one OSC library that I found on Arduino. I found many when I was trying to do this. This one seemed quite simple, so I just used it. What you do is what's called add a callback. And you say like every time that I receive an OSC message of this type to board, do all of this. And what this is like light up the built-in LED and then print the value that you get on the serial monitor and set the PWM value to channel and resolution doesn't matter now. What you do here is like change the frequency to the value that I got from the message. Okay, so what the message is gonna look something like that. This is what the message that I'll get will look like, because the slider gives a value from 0 to 1, and then to board is the message, right? So this value is going to be in this structure here. And I'm just gonna pass that structure as the frequency of my PWM function that I found for the ESP32.
Do you have this code already in your documentation?
Of course, man, of course. Yeah. And then on the loop function, what you just do is like listen for OSC and then write. It's called LED. See, it's just because the way they called it, that you can like PWM anything. So write to this configuration, which has like the frequency, the resolution, and the channel to this volume. So I'm just gonna fix the volume right now to 200 and then change the frequency, okay? There's only, yeah, let's do that. So this is the Arduino part. Again, important things, Wi-Fi configuration, set the listening port. This is the PWM reference. This is how you have to use it, and then subscribe to a message and do something when you receive the message. That's pretty much it. On the Unity part, same as Arduino, there's like many different OSC packages that you can use. I found one that's really easy to use, that you don't even have to program anything. It's called OSC Jack. It has like a sender and a receiver. So obviously I want to send, okay? So I'm just gonna go into my slider, attach the sender to it. Okay. Now my slider has this new script that I just attached it to. And this script has like exactly the name, the parameters that we need to change. Where are we sending this package? The address that I had set on the Arduino side. What port? 8500. What message am I sending to board? Yeah, remember all of this is here. 8500 to board, 10.00.20. Data source, this is the important part. What thing do I want to send? I want to send stuff from the slider. What component of the slider do I want to send? The
slider inside that is the one that it has the value?
Yes. There. We want to send this value, right? So we need to see what component this value is in. and it is the slider. So I don't know why I'm not seeing. Oh, sorry. Slider. I had dragged something else. Slider component. So slider is the game object first. Okay. This is the game object. Inside the game object slider, we have the slider component. Maybe I could have called that different. I'll just change the name. My slider. It's going to be less confusing. So that my game object is called my slider. Inside my slider, I have the component called slider. And then of this component, I want to send the value. Okay. Lastly, what this has is like keep sending yes or no. If you don't check that, you will only send it once. If you check it, it will send it constantly. So I just like keep sending OSC messages constantly to the Arduino. Okay. There's one last thing that we need to change here, and it's that if we keep it like this, we're going to send values from 0 to 500, and we're probably not going to hear anything at frequency 0. So I'm just going to say 440, which is an A, to, I don't know, 800. Okay, these are the frequencies that I want my speaker to vibrate. And this is pretty much it, I think. Let's let's give it a shot. Remember that to test this, I don't have to like build the APK all into my phone, load it and everything. I can just like hit play here, and all of this should happen the same, right? So I can like debug and iterate much faster. So I'll plug the STDI cable in. I'll lower my camera so that you can see this right there. I'll hold this guy in there. Okay, so this is a 440. That's ugly. Now when I hit play,
Amazing.
all right, we got it. We got like 2 assignments done, like networking and this one.
Well done.
So maybe as a last thing, because this looks really ugly, we're just gonna make it like slightly more better looking, okay? So what I'm gonna do is, I'm gonna get rid of the button and the cubes because that's kind of useless. And the rotator because we're not gonna rotate anything else. And this is what I'm gonna do. I'm gonna, first of all, grab my slider. I'm gonna rotate it and make it vertical. And I can adjust the rotation here to make it like straight. And I want the whole screen to be sort of like a theremin, where like if I drag on the bottom, I'm gonna be on the low frequencies. If I drag on the top, I'm gonna be on the high frequencies, okay? So what I'll do is like I'll turn my whole screen into one giant slider. That's the easiest thing I can pick up. If I had to do this for real, I'd probably not do it this way. But since we have the slider and all the code, I'm just gonna do that. So look at that. I'm just gonna make the slider as big as I can to take most of the screen. I'll make the handle slightly bigger because you can barely see it right now. So that'll be here, handle. I'll just scale it like that. Now you're gonna say, dude, this looks like even worse than before. True, but what I'll do is I'll just hide these things. So each of these elements, remember, it has like an image component which has a color. If you go into the color and change the alpha, it goes away. So I'll do that for the handle, the background, and the fit. Okay. Our slider is still there, but we just don't see it, but you can still interact with it. Now, to give some sort of feedback that something's happening, I'll just add a UI element that's called a panel, which is essentially like a square. It has nothing. And we've changed the color of this panel. Depending on the slider, okay? So, yeah, I'll use this code here, which is, it receives an image element, which I'll call panel image. And it has this function called change color that receives the parameter. And what it does is it sets the color of the whole panel to this thing. This can be a bit confusing. But let's see, how should I explain this? This would be the same as saying like color C, I'm gonna create a new color, it's new color. And then RGB would be like F, because we want it, for instance, like we want it red, and then 0 and 0, okay? And then panel image.color. This is exactly the same code, maybe it's easier to understand. As one last thing here, like this number is going to be the slider, okay? So the slider value, if you remember, it goes now from 440 to 800. And the color values in Unity go from 1 to 0. So we need to just like change that, yeah? So I'm gonna say like red will be, let's say it will be like F minus what for 40 divided by, what was it?
Can we map it, like remap the, like putting like, I don't know, like processing, you have a map function that you can map the value from this to this?
You can totally do that, but since it's a linear scale, you can do it. I'll just look for it. I used it many times. You know, it's actually curious. The Unity has a built-in function to do that, but I have never found it. I know it does. So I always end up using this like Wikipedia page with this function that does that essentially. Okay, so let's use that. So red is gonna be map my F from 440 to 800 to 0 to 1, yeah? It's a good practice if you're doing a floating number to add this F value at the end of the number. And now I'm just gonna do that. Okay. So again, like we're getting an
the F at the end of the number is to state that that is a float. It's not an integer. It's a float.
Exactly. You know, sometimes you don't need it, but I think it's good practice to avoid some errors. Sometimes when you do divisions, if you don't have that, it starts like rounding numbers when you don't want to. So I think it's good practice to do that. So yeah, we're mapping the value of the slider that goes from 440 to 800 to a 0 to 1 range. And then we're setting that number from 0 to 1 as the red component of my panel image. What do we need to do now is go into my slider and we don't need this anymore. When you change my slider value, I want you to, I don't need this anymore either. I'll use the same UI control game object. I'll attach my call script here. And this panel image that I need to change is just the panel that I just created, okay? Panel has an image component. So I'll just like drag and drop this guy here. And now it's attached. Okay, so now if I change my slider event to UI control, change color. Let's give it a shot. I'm just clicking with the mouse, okay? So it works. All right. I'm gonna build the APK again just to like wrap up this first part of the tutorial. I'll call it theremin now, because it's pretty much a theremin without the volume or the modulation. Plug in my phone again. All right, this is my phone. This is a theremin APK that I just built. We made it slightly smaller by removing that crap. Good. So now we have it in documents. I'm just gonna close all that. And now, moment of truth. I'm gonna do this again, sorry. Theremin, install, open. Okay, this seems to work. So now let's just go back to this guy. All right. So yeah, this was pretty much what I wanted to do for the first part of the class. We've seen basics of Unity. We've seen how to create interfaces, and we've seen how to interface with Arduino or any board that you have. The last thing that I want to tell you is like, if you don't want to go this Wi-Fi and OSC route, you can also like write stuff through the serial port on the USB. And I think I had a snippet here somewhere. Yeah, I'll just show this to you. It's like a GitHub page. I'll paste this on the chat so you have it. If I find it. I'll send it to you later on. Yeah, this is how you write stuff on the serial port from Unity. You just need like to access this guy, serial port. Call it anything. This is just a name. Okay. And then open the serial port with the baud rate. Call open to open it, and then write anything you want to it. Okay. The Arduino part. you would essentially, I mean, you've seen this before. If there's values on the serial data, read them and then do something depending on the value that comes in. Yeah. So it's much easier to test, but I thought it would be fun to see the OSC part. All right, this pretty much covers like the basic part of the talk. So maybe we can take a 5-minute break now. And then on the second part, I'll speed up and go through other stuff that you can do with Unity, which goes obviously beyond the moving cubes and moving sliders. Okay, sound good?
Okay, cool. Thanks a lot.
Super nice, Roger. Thank you very much. Now, Hada is not here. Okay. I wanted to ask her how are the MDF students. So if she knows that anyone is coming or not. But there's no one, so it's okay. Let's continue and they will see it recorded. Okay, so
No problem.
perfect, Roger. Super nice class. ¿Qué tal? Ve cómoda, sí, ¿no?
Sí. There's I want to say there's
I will pause the recording, okay? For this minute recording. Okay, recording now. So all yours.
Okay. So yeah, in the second part, just gonna cover different parts of Unity much faster than before, just for you to see what you can do with it. And I want to start by talking more about materials. We saw the Fab Academy cube before briefly, but I want to tell you a little bit more on how they work and what types they are and different options that you have. So as you saw me doing before, when you, hold on, let me hide this. When you create a material down here, it just like fills this up with default values and everything. But you have like plenty of stuff here to play with, okay? Like the most basic thing is like if I attach the logo to, what's the base map? I can play with the tiling, so to repeat the texture many times. Offset just moves it without moving the geometry. I can change the emission color, so that means that it will actually be emitting light of this color. Okay. You usually can use what's called a normal map and a fusion map. Normal map is interesting. It simulates like a 3D effect without actually having a 3D. And then you have like different modalities here that you can play with. You can make it transparent and whatnot. Make it only render the front faces, the back faces, or both. There are many types of material. This mobile category, for instance, it's really good for if you're building for slow processors like mobiles, tablets, or all PCs. Nature is good for stuff like trees, UI, we just saw it. VR and AR have like some special materials that you can use in some cases, although never done much of that. Particles, we're gonna see in a few minutes how to use particles. Skybox is a type of material that's interesting that essentially covers the sky with a texture, making it look like you're inside a giant dome, if you will. Unlit is interesting too, in the sense that it's not affected by light. So I'm just gonna do like a quick demo of this. I don't even want to name that. I'll just like create 2 cubes here. Where is my camera? Oops. One of these. Okay. So we have like a one unlit material and one lit material. And what different is that if I change the lighting, the lit material will change, but the unlit material will not, because it's not affected by light. That's really important. That's how you simulate, for instance, when you want to have a light in your scene, you want it to assign it an unlit material because it's emitting light, right? In any case, so you can do a bit with these default parameters here on materials. You can do pretty much anything you need, I would say, for normal games. But if you want to take it a step further, you can do it two ways. Like the old way would be to write shaders yourself. Shaders are what define what a material does. And it's kind of like a bit complicated. I really like this website that I'll show you in a second called Shader Toy, where you can see a shader language. Shader language is usually in three different variants of language. It can be HLSL, GLSL, or CG. Okay. What's fascinating about this is that these examples are GLSL, for instance, which use OpenGL. HLSL uses DirectX, which is the other 3D option that you have when you do this stuff. And what's interesting about these things is that you can do so much cool stuff with little code and no texture or anything. Everything's procedural. So what you see up here, it's just this code and nothing else. It has no textures or anything. Just with this like highly mathematical low-level code in here, you can simulate these kind of things. Okay, this is a shader. Sadly, this is in GLSL and Unity uses HLSL. So you cannot directly copy paste this into a Unity shader and use it. But there are ways to do it if you want. I wanted to show you like another shader that's really, really cool. All procedural stuff. This one, simulation of water, pretty impressive. This code is a bit long, but if you look at the detail of this stuff, in just like 200 lines of code, no textures on anything, no skies, no lights, nothing, it's pretty impressive.
And then you can use this shader in your game, right?
Yeah,
as a texture.
Mm-hmm.
Okay.
If you use this it's not exactly as a texture, it's like a material. And then if you assign this material to an object in your game, then it would look like this without having actual, it could be like a cube. So, you know, 4 vertices, but look like this because of the shader, right?
Okay, great. Yeah.
You can also do music with shaders, which is really impressive. Like this website, check it out. It's I'm not gonna hear because I don't have the audio from my computer. But if you go to the front page, Shader Toy, there is browse. There's this like SoundCloud input, and you can just like plug in music, and then you can do stuff with shader code and music. It's pretty impressive. Not what it was meant for, but you know, people are really creative. This is the last one what I wanted to show you. Oh man, this is really slow. Okay. This one actually uses a couple of textures, like these 3 textures that you see here. But with only these 3 textures and this piece of code, it is able to generate this mind-blowing thing. It runs smoothly. Like the casting on the screen is not great, but it like runs really smooth on the PC. All of this is procedural, completely mathematic, with only 3 textures. It's pretty insane. So what do you do if you are not good at HLSL or GLSL, as most of us are, because it's like really complex? not long ago, Unity released what's called Shader Graph. They actually bought a company that was called Shader Graph. And now you can like produce shaders by just drag and dropping stuff in a graph way. So you start with that. Okay. So like a PBR master. PBR stands like for physically based renderer. And let's say that we want to create a node here that's a texture. Maybe a 2D texture. I'm going to use the only texture that I have here, which is the FabLab one. Okay. And as soon as I plug that into the albedo field, then we have that. But obviously you can do much more, right? So let's try to affect this somehow. There's a cool node that's, for instance, Voronoi noise. Let me just type it. The cool thing is that for each step, you can see the results before you actually produce the your shader. So if we take this Voronoi and we sort of like, for instance, mix it with the output from the texture with the blend box, we're gonna have something like that, which is still not too exciting, right? But it's something. We can make it darker maybe. Wait.
Sorry to interrupt you, Roger.
What?
Are you in the first part of the class or in the second one?
No,
I have to leave and I come back now.
This is the beginning of the second.
Ah, cool. Okay, sorry.
Right, so, and then there's other stuff that you can do here where, say like we want to move this texture, right? How we would do that. So in here we have like the offset of the Voronoi noise, for instance. That if we move it from the fixed parameter, you see that it changes. And the way to move that is, for instance, using time as a variable. Time is like something that's completely incremental in Unity. It just like goes on. So if we plug time into the angle offset, you'll see that this guy starts moving. It will just like keep on moving forever. And now our texture, I hope you see it, it's just like an alive texture all of a sudden. Yeah. If we want to make this faster, the only thing we need to do is like go to like math, basic, multiply, and we're just gonna multiply time by 2, why not? And now these guys are much faster, yeah. So this is like the basics of how to use a shader graph. You just concatenate these things and you would be amazed at what people do with it. I'm something like not an expert in this. But once you have this guy, let's say that we're happy with this, although it's not too exciting, but we're gonna save this. And we're gonna create a new material. New. And the only thing you have to do is like drag and drop this graph to your new material. And now your material is your shader. Yeah. So why is it not moving? Because shader needs time and we're not executing. As soon as I hit play, you see the cube start moving with the Voronoi noise. Okay. So these are like the essentials of the shader graph. Since we're here, I don't know why, but I had in this example, I had the Oculus preset here. I'll show you how to build a VR application. I will not do it because it takes time compiling, but it's really, really easy. The only thing you need to do really is go to the asset store that I explained on the first part. And if you're building for Oculus or Vive, if you're building for Oculus, you just look for Oculus. And you have this package come from the Oculus Corporation or Facebook, essentially. And if you're building for Vive, you go from SteamVR. and you have this package here, okay? You download them, and in my case, I have a Quest, so I downloaded the Oculus, and then you have this folder here. It has like a lot of stuff that you're probably never gonna use, but you know, it's better not to touch anything. What in the end you end up doing is like going into VR prefabs and just like putting the OVR camera rig in the scene. What this is essentially is like a VR camera. Remember, the camera is everything that you need to see in your game. So by using an OVR camera, now, I hope this doesn't take too long, honestly. Now this is a VR application. If I were to build this, put the headset on, I would see this cube in 3D right now, inside the headset. It's that easy. And then I would remove the default camera because I don't need it anymore. Okay. You don't have to do anything else. It's this easy. Inside here, if you want to do some more cool stuff, you have the access to the controllers. So left hand and right hand will take values as soon as you turn on the app, and the two Quest controllers will be alive in these objects here, and the position and rotation of these will change in the update method, essentially. So you can do anything you want, and then you can control for like the clicks on the buttons and all of that. But seriously, this is the only thing that it takes to build a VR application, nothing else. Okay. I'm gonna talk a bit about something called terrains, which is interesting too. Let's right here. Because remember, like Unity is obviously like a game engine, and one thing that many games have is like a world that you play in. So Unity has a thing to create worlds or levels, planets, whatever you want to call it, called terrains. The way to access it is, again, right-clicking there, 3D object, and then you click terrain. And you'll see it has created for us this huge plane, huge platform, okay, with nothing, it's all flat. And then inside this terrain, you have like different tools here, kind of like a Photoshop, if you will, where you can paint stuff with different brushes. And one of them, for instance, is the raise or lower terrain, okay? And this is to create mountains. You can pick your brush, whatever shape you want to paint in. You can change size, and then you start creating mountains. That's it. You can, if you're not happy with it, you can smooth it a little bit. It looks too abrupt. Then you can give it a texture. And to do that, you have to add what's called layers. You can have as many as you want. I have a couple here that I downloaded before, which is like essentially grass. Now you see that everything turned to grass. I think the grass had a normal, yes. A normal map that will give like a bit of a 3D feeling to it. And then I can add another layer. Create a new one called rocks. Okay, and these rocks also have a normal map, and then I can paint, let's say, the mountains with rocks. All right, make this bigger. And just like that, little by little, you start building your worlds. What else you can do is you can add like plenty of trees. So if you have tree objects, I have some here. I'm just gonna add them to my repository and put this guy in there. And again, you just like paint trees with that. You can add grass and what's called details, grass, flowers, stuff like that, bushes. And add some grass here. And same thing, I'm just gonna use another brush. I can do that now. Okay. We're not gonna see it now, but as soon as we get close to it, we'll see it. And then, okay, let's move our camera closer to all these. Oh, yeah. So you can see the grass, the trees. Obviously, you know, I'm doing this really quickly. And the mountains in the back. All right. We can add some flowers, I think we have. These are all textures, so they really don't take much space because it's a transparent texture rendered on a plane. So a plane has only like 4 vertices. It's nothing. Take this guy, put it there, and try to paint it. Oh, too many flowers. Okay, it's fine. They're just like blended with the grass, so we can see them. In any case, that's the idea. You just start like building stuff like that. Now, one other cool thing, another interesting window is the lighting window, which is inside rendering. In here, you can control everything related to lighting, obviously. When you deal with lights and shadows, you have to be really careful because shadows takes a lot of computational power. So by default, Unity uses like real-time shadows for everything. That means that it's calculating all these shadows in real time. If your objects don't move, it doesn't make any sense to do that. So you do what's called baking the shadows, which means like calculating a texture with all the shadows on the texture and then just applying that texture and not calculating the shadows for the objects in real time. And then you can apply much more shadow detail because it's something that happens offline. So all these parameters are in here, but another parameter that's interesting is the fog. And that always adds kind of like a bit of realism into your scenes, see? Kind of like a more spooky. You can have maybe like a, let's do that. Okay. Another thing I haven't talked about yet is physics. So I know that both when Victor told us about Blender, he showed physics. Edu has showed physics with Rhino and Grasshopper as well. You can do a lot of physics in Unity, and to do so, I'm just gonna try to put some stuff in front of the camera here so we see it. To do so is as easy as just creating any object. This guy, okay. And by default, as we talked before, it has like the transform, which all of them have, the mesh components. And it always comes with this guy called collider, which is 1/2 of the physics. The collider is these greenish outline that you can see on the edge. And this determines the boundaries of this object when you use physics to collide with other stuff. You can change it here if you want. You'll see how this moves. If I do this, then this object would collide with things outside of this area, which is obviously not interesting. The other object that's not included by default is something called a rigid body. And when you add this component to any object, then immediately, if it has gravity, when you hit play, it'll just like fall down. And it just like that sunk into the grass, right? Let's make it bigger. I'm gonna move it down. And then obviously, like all the physics calculations are done for you. You don't have to do absolutely anything at all. If you add more stuff, like a sphere, for instance, just gonna put it there under the cube. And I don't add a rigid body to the sphere will just remain there, and this thing will hit with the. Okay. So it's really easy from code to detect when an object hits another and to know which object actually hit the first object. And it doesn't take that much computational power. You'll see, we're gonna go crazy here. I'm gonna add like a shit ton of boxes everywhere and see what happens. Okay. Make some copies, move them slightly. I could do this by code programmatically, but I'm just lazy, so I just like move them slightly up and down to the left and right. And then I'll duplicate all of these at once again and move them. And all of these at once again and move them like that. So now you should see like a rain of boxes falling down, all of them hitting and staying there in the ground. So it's really easy to do stuff with physics, and you end up using in almost all the games. Another, you can get more complex than just like box collider and rigid body. If you go to add component and visit the physics department, it has like spring joints, hinge joints, fixed joints, cloth simulation that you can do. So it has like plenty of stuff to play with. And yeah, okay, let's do one last thing here is how would we move a character in a game, right? So to capture keystrokes, I'll just create a script, I'll call it control, for instance. And in the update method, I will listen for keystrokes. The way you do that is like, if I get the key, let's say key code, okay, that means that if you are pressing the up arrow key, I'm just gonna do translate in direction forward. Forward is a constant that's always like pointing forward to the object that you attach this script to. So if we attach this script now to our camera, and I hit play, and I click the forward arrow, I just like go like really fast. Okay. Obviously, what you would do is just like half again like a public parameter speed, maybe, and then multiply that by speed, and that would be much slower. Okay. And then you can just like replicate this to go down, left, right. And then instead of forward, I would go back, left. And now I should be able to fully control my guy in all directions. Yeah. let's say we want to, yeah, make this, I'm just gonna create sort of like a bullet if you want. Not gonna go crazy with it, I'll just create like a red sphere. And I'll say like, you know, every time you press space, so hold on, like this bullet, I want it to have physics as well, because I want it to fall down. So I'm gonna have the rigid body. It already has a collider, so rigid body. Yeah. So I'm just gonna say like, you know, if you press, if you press space, I want to change this to key down because I only want it to happen once. If I do get key and you hold the spacebar for 1 second, it'll happen like 60 times. And key down, it will only happen once. Then you can do key up to on release if you want. In any case, if in space, I want you to, first of all, instantiate, which means in a runtime through code, create an object. I'll create a bullet in where you are, that's fine, in this position, and with no rotation. I need to define what bullet is, so I'll just go up here, assign a game object component. Okay. And go to my camera that has this script, and now assign what a bullet is. So what bullet is like my red sphere. And I'm going to leave that one on the scene. And now if I click play and hit space, where's my camera? Okay, I'm spawning balls here nonstop. But this is not a bullet, right? We want to shoot it. So the way you do that is use the rigid body and do something called add force, for instance. So what we'll do is like, with this game object that we just instantiated, which is the red bullet, I will get the component that's the rigid body because I want to do stuff with it. And what I'll do is add a force. And what's asking for is a vector 3. So for now, I'll just like shoot it forward. Let's see what happens. What this will do is like press space, instantiate the bullet, and then add a force to it forward. Okay, that didn't work. Let's see. Maybe it wasn't strong enough. Oh, there we go. Now it's kind of like shooting it forward, but we need much more strength, right? So obviously the right way to do it is to create here a new parameter called bullet speed, maybe like 1,000. And wait, change these for bullet speed. Okay, well that's not bad. So I can now like go around shooting stuff. So it's looking like a video. And we'll leave this example here because you know there's not so much else to see. You could obviously like turn the camera with the mouse. That would be like the first thing to do if you wanted this to look minimally acceptable. But you get the idea. Like what I wanted you to see here is shaders, the shader graph option, how to create terrains, and how to interact with keys. And if you had a joystick, for instance, what you would do is call this input that joystick.
Can I ask you a question?
Yeah, go on.
While was you shooting, it was a lot of like a sphere object that is adding to the scene. Could we just like buffer them, like remove them while we're like doing this?
Yeah, you would definitely do that, right? Otherwise, like after 10 minutes of playing, you would have like 10 million bullets on your scene. So, you know, let's do that. Actually, it's a good call. What I would do, I probably would not do this, but this is an easy way to do it. I'll make a script called bullet. Okay. And then what I'll do here is I'm just gonna save a floating point number called spawn time. When my start method happens, which is when I shoot the bullet, I'm gonna assign this spawn time to whatever time Unity has, okay? And then in the update method, if the current time of the scene, which is something that keeps increasing, minus my spawn time is, I don't know, bigger than 5, that means that more than 5 seconds has passed, I'm gonna destroy this amount. Okay. And then if I assign this bullet into the sphere, okay, now the sphere has this script that after 5 seconds will destroy that amount. And we're not gonna have that problem anymore. So I'm just gonna shoot one. We lost, it's right down there. And it's gone. Yeah, so there's no sphere anymore. So that's something that definitely you need to take care of. Otherwise, your game will crash really fast. All right. Let's see. Next, I want to tell you about particles and what's called post-production process, post-processing, sorry, and something called VFX, which is something relatively new, which is like particles on steroids, essentially. And this was, yeah. Particles is something that you know, always adds a lot of realism. So look, imagine like this bullet that we were doing. If at the moment of pressing space and shooting the bullet, you create like sort of like an explosion with a smoke or something, then it will look much more realistic, right? And the post-processing stack allows you to add effects at what's called a screen space level. That means that you don't have to, you don't worry about the 3D elements on the scene. You wait for the whole rendering process to finish. And then once you have like the final pixels, then you apply a filter onto those pixels. Okay, I'm just opening the project that I had. It's taking a while. But with post-processing, you can do stuff like bloom effects, which make like shiny stuff shinier. You can do color grading, change the color, tone mapping. You can do depth of field, which looks really cool. So you'll see, yeah. Do I have? Okay. I just had this thing. By the way, I have a skybox here. I mentioned the skybox before. This is what it looks like. Once you apply a skybox to your scene, to your camera, then it looks like that. You have like a full galaxy or whatever material you have. It can be inside a cave or anything. And this skybox doesn't move. It's always there. You can go as far as you want. You will never reach the end. Okay, it's just like a permanent texture around you. So I have this scene here. Easy. My camera, 3 objects at different distances. Okay. And the first thing that I wanted to show you is the post-processing stack, which is this guy. And it has like different effects, as I said. Like all of these, you can add grain or vignette effects, lens distortion, motion blur if you move. But I'm gonna start with these. Ambient occlusion is a really interesting one, which adds more quality and realism to the shadows without the performance hit of actually having to calculate the shadows. So if I turn this on, you will notice these sort of faint shadow around the edges that adds more and more contact or surface to the objects, right? Let's zoom in here. You focus on the floor. It's fake because it's calculated after all the shadows are calculated, but it always adds like a lot of realism to it. Another one is depth of field. If you want to simulate like how cameras work, this is really cool. So you can touch the parameters here. As you can see, when I change the focus distance, the elements that are on focus change, right? So for cut scenes and stuff like that, this is really, really interesting stuff. The bloom, as we talked about, makes everything shinier. And it's a good combination to do color grading with bloom, which adds contrast. So you can see the difference between before and after. Before and after, much cooler. All right, so particle systems, really fun stuff. To create a particle system, actually I'm gonna leave the plane here. Right click, effects, particle system. And as soon as you do that, you have a particle system just emitting particles out there. So first thing, I'll move it right there so that it's not sunk into the plane. And maybe center it. Particle systems have like a shit ton of parameters. You'll see like all of these here, and then for each of these, you have like several parameters inside. So you can like really, really go crazy in parameterizing these things. But I'll just like play with this one, something simple. And I don't know, we can start with changing the size, because I think these balls are too big. And I want to make random value between 0.1 and 0.5 or size, so you can see that they're different sizes now. I want many more, so I'm spawning 10 per second. I want like 100 more. Let's say 200. The shape, I have a code now where you can change the angle. But I think there's a little hemisphere, just like shooting particles up. Only like on the top half of the sphere. Yeah, so we don't have particles down. And one cool thing is that you can add gravity to these particles. So if you add gravity to them, that's probably like too strong, so they're falling like too fast. If we start like ramping this down to 10.1, yeah, kind of looks like a fountain. Okay. Another cool thing you can do is this trail thing, for instance. This is interesting. These renders align from the beginning to the end of every particle. Now it looks like crap because we haven't assigned the material to the trail, but as soon as I do, to have here, kind of looks better. It's way too big, obviously. So let's go to the trails width or trail, make it really small, maybe even smaller. Yeah, that's cool. So, and you know, this is a particle effect, so you can move it and put it anywhere you want. Now, when you have what's called simulation space local, okay, wherever you move your object, all the particles go with it. So that sounds kind of like unrealistic. If this was like, I don't know, a firework or a fountain, this would not happen, right? I would not move the fountain and all the water would move with me. So what you do is like, if you set it to world, now all the particles, once they're spawned, they are where they are. And if you move your shit, then it just stays there, okay? If we enable the post-processing, oh, it's enabled, okay. No, it's not. So yeah, I don't know, let's make a quick script here that, actually I think I have it, yeah. Okay, I'll show you this one. I'll just add this to the particle system, which just moves the particle system up and down slowly. So we have like this kind of light palm tree if you want, which we did in like 5 seconds. So I wanted to show you this script because you could move objects. I'm pretty sure you could code the moving of the object really easily now, like move up if you hit this height, then move down and so on. But Unity has like all of these shortcuts and funny stuff that you can use. So what I'm doing here is ping-ponging the Y component of that particle system. And ping-pong essentially means that it goes back and forth from one parameter to the other, okay? So I have this parameter max Y, which is like 5 units up. And then the init Y, which is the initial Y component of the particle system. And when I do this in the update method, it will just like ping pong between essentially the initial component and the max Y component at whatever speed I tell it to. So if I change the speed here to 10, it'll move much faster. Although, we don't really see it because the particles are so slow that it doesn't really make sense. Anyway, these are classic particle systems, okay? Unity came up with a new way to make particles. I'm gonna move this guy further away. Where's the camera? I'm gonna move this guy down there so that we can draw the stuff. Okay. Get rid of this. So this new particle system process that Unity has, it's called VFX. And by the way, I should mention, like Unity is very modular now. It was not like this 4 years ago, but since then they released what's called packages. So you go to Windows Package Manager, you're gonna see all the packages that you can install and uninstall on Unity. All of these things add new functionalities to your scene, okay? So you have stuff from the shader graph that we used before to support for the rider editor, which is another coding option. Polybrush, I'll show you later on, stuff for VR, different rendering pipelines for different platforms. Google Audio, never used that. Anyway, so VFX is one of these new things, visual effects graph, okay? If you want to use it, you need to add this package before you use it. And the way you create a graph is just by going here, create as usual, visual effects, visual effect graph. Okay. And this looks very similar to the shader graph model, actually. You'll see. We'll start with this one that doesn't do much. You'll see in a second. If I drop this guy into the scene, right there, this is my VFX. It's pretty similar to what we had with the initial particle system, right? The difference now is that instead of all that, those madness of parameters that we had, it's much more compact and readable here. We're spawning at 16 rate up to a maximum of 32 at this speed in this direction. We don't do anything when it updates, and then we render it as a quad with this texture that you see on the scene, and many different things. If you want to add stuff into these guys, you just press space and then add, I don't know, I'm just gonna make this up, gravity. And now they're falling down, okay? It's really cool. It comes with some pre-made, which is what I used for one of my assignments actually, something called Swarm. It looks really, really cool. Yeah, this is by default without anything. You have like a really cool particle system. And this one you can you know, change some parameters. We can add some gravity again, but smaller one. So instead of -9, I'll say -1, and then sort of like 10 to fall down. We can make it more. This is called turbulence. This shape of forces, where we can make it more intense and make it crazier. We can change the colors from these yellow to, I don't know, it's like bluish to greenish, and so on. The coolest thing about this is that you can expose parameters, and then you can control those. Obviously, the I'm just seeing the shared screen now. It runs much faster than that. Okay, it runs like really, really smooth. You can expose parameters, and then touch them or access them through code. So I create a new float here that I'm gonna call whatever, intensity. One, and I can just like drop this guy here and link it to this guy. Okay. If I click expose, now my particle system has intensity here, which I can control from outside of the graph and through code. Yeah. So this is like the new way to create particles. It's really, really powerful. I'll share with you a video just to see what you can do with, you know, if you put time into it. I hope you see it okay on the in the share screen. Yeah. All of this is done with the with what you just saw. All of this. And it's also, so the difference between the new VFX system and the particle system is that this new VFX system uses the GPU to calculate the, so if you have a GPU, which is normally the case when you play games, you can do so many more particles, like millions of them, without taxing too much the computer. Whereas normal particles actually are calculated on the CPU, so it takes more time. All right, last block I wanted to show you really quickly is something that's quite new too, called ML agents, which is how to use deep learning into Unity, which I think is fascinating. I played with it a little bit. And it's been in beta for a long time, but I think it's like, you know, totally out now. And what you do is something called, maybe Oscar will teach us more about this. It's something called reinforcement learning, which essentially is like teaching a dog, if you want. And you know, your character or your enemy is doing something, and every time it does something good, you reward it. Every time you do something wrong, you punish it. Okay. And then you don't teach him anything else. You just like give him the variables that he can play with, and then reward or punish. And you let it run for, I don't know, an hour or two. And in the end, it learns by just like trial and error how to do what you want him to do. So in this example here, these little guys, we will train them to hold these balls on top of them by just rotating either in this direction or in this direction, okay? So the, let me see if we, because obviously I'm not gonna train it in real time because it would take like an hour or two, but, so I just disabled the pre-trained training that they had. Now they have no idea how to do it, no idea. So what the model does is like when you start, it applies to random things. It applies a random rotation to every guy and a random position of every ball, okay? As you can see here. And now you're telling them essentially is like, okay, you are going to be rewarded if the ball doesn't fall off, and you're going to be punished if it falls off. These are your two variables, this rotation and this rotation. Play with it. You see that initially they have no fucking idea what to do, so they just stay there. Like they're being punished and punished and punished. Okay. I assure you, because I've done it, if you let these play for an hour or two, you have a GPU. They start like moving more and more and more, and you see them learning actually in real time. Once they have trained, I'm just gonna assign the pre-trained results. You'll see that, what is it? Again, I'm gonna hit pause so that we can make sure that all the balls are in random positions and all the rotations are random. Yeah, see. So once they're trained, check this out. Magic, intelligence. This is fascinating. And again, this only takes like 1 or 2 hours in my experience to train these guys. And I'll show you the code. It's actually not that hard. It's just like maybe like 100 lines of code, even less probably. Yeah, there you go. In summary, this is what you're observing, the rotation on these two axes that I told you, the difference between the ball position and your position, and the velocity that the ball, the faster the ball is going, the worse for you, okay? And then these are the conditions kind of, like, and essentially it's like, hey, did your ball fall off? Stop and punish. If not, maybe you're doing right. So I'm punishing you -1, I'm giving you a 0.1 cookie if you want, okay? This is all it takes. Really easy to do. There are like many examples here. If you download the ML Agents package, there are many examples. There's one that I really like. I think it's this blocker here. Yeah, this is fascinating. This is much more complex because it has each join of these guys is a variable. So whereas before we had only 2, now we have maybe like 15 or something like that. And where you're teaching these guys is not to fall off and to walk forward, okay? And once you have this, they're basically learning how to walk from scratch, from nothing. I don't know what my camera is, but it's not following them. Anyway.
And what is the difference between teaching them with machine learning or just program them with code?
It's different. If you think about the example before, in no case we say like, if the ball falls in this position and you are rotated like this, do that. So that code is not there. The only thing we do is like, if the ball has fallen or the ball is about to fall, you're doing bad. If it hasn't fallen, you're doing good. And then by iterating many times without what's called heuristics, it just learns to maximize this reward. And that's what it's trying to do. It's maximizing the reward. That's everything that's trying to do. And what's cool is that you can actually, and you know, these ML agents are prepared for this. You can actually apply heuristics if you want. And that means like human knowledge, okay? So in these guys, I could say like, no, look, when you're learning how to walk, you would never throw yourself into the floor as a first step, okay? What you would do is like move your right foot forward. And then you're gonna save like hours of training because they know that if you give them this information, but it's your choice. So let me, because I wanna see one of these guys walking. There we go. We're gonna see it here. And it's sort of like kind of like a race.
So you teach them to react to a variable without knowing what the variable is, right? Like to be able to prevent some actions or something. To teach how to learn and not just teach.
Yeah,
Oh.
exactly. Yeah. They're learning from scratch, or
Yeah.
but the important thing is that we're not programming them to do anything. We're just like saying maximize the reward, and then when you're training, you're saving these files constantly. At any point, you can stop the training, and then you can do what's called inference, which means like with everything you've learned, now do it. Okay. And yeah, so as you saw here on the 3D wall example, when you train, it's convenient to train many times. So in this case, it's just training like 12 guys at the same time, and they all share the knowledge through these object called Academy, which is, again, like the code is super simple. So it's really cool. There's another like tennis one is found here.
And what kind of data do you store? Like, is there a database of good and bad thing to do?
I have no idea about this, honestly.
Okay.
You also would know.
Is this something you can also share, like to train variables, to train behaviors, and then share your knowledge to someone else to start from it and not from scratch?
If the conditions are the same, yes. That means like the same ball mass, the same area, the same rotation degrees of freedom, and all of that, you could totally like port it over. This is actually that I thought a crazy idea was to train something with like a replica of the KUKA model here, and then port it to the KUKA so that it moves, having learned something from scratch. I don't know, that would be insane.
Just to add a little bit to that, sorry, I was in the shadow during all your fantastic class, Roger. We will talk a little bit about machine learning. Well, we already started a little bit, but basically, when you train one of these algorithms, you like, it depends on the type, but you probably, if this is like a decision-making algorithm, which is basically if this happens, then do this, then otherwise do that, and then if that happens, then do this, and then do that otherwise, then you have like a decision tree or something like that in which you assign probabilities and all that. What you basically save is what you call the weights of the algorithm, which is basically the numbers that you put in each of the nodes to decide what to do next if this happens or other thing happens in somehow a probability. And that it can be just like a text file, basically, that has some sort of coding. And it's nothing like super complex. Actually, in 2 weeks, we will talk about a little bit machine learning in computer vision, and we see one algorithm is called YOLO. And the power of that algorithm is not only that you have a good algorithm, but also that they shared a pre-trained model that is quite heavy. It's like 500 megabytes already for the training, but already you can start with that and then build on top of that or improve it or add different decisions. But of course, as Roger is saying, if you get out of those conditions, then you're gonna, for example, if you see, I don't know, this thing in the video and the algorithm only learned to detect pens, then it's not gonna know what this is. It's just gonna know what you train it to do. And if you train it again with this in the training dataset, then it will be able to detect it.
Cool. Okay. So the last thing I want to show you, and then I'll just show you a couple of videos and I'll be done, is something called a profiler.
Just to say that this tennis game was fascinating to watch while listening to this.
What's that?
talk. Yeah, the tennis game, like the racket playing tennis right now. Just
It's
learning how to
fascinating,
play. Yeah, very cool.
Okay. So yeah, I want to show you something called a profiler, which is here in analysis. It's a really interesting tool when you start having tons of things in your scene. It's not the case right now. You can use this guy. That's basically analyzing everything that's happening on your scene at every level, okay? So what is the CPU doing? What is the GPU doing? what's the rendering stats, how is the memory being allocated, if there's audio or not, video, physics, networks, UIs, illumination, everything. And you can go really deep into it. So if you look at the CPU, for instance, you can click there and the game pauses to analyze this frame. And then you can look at, hey, what is going on in my scene? All the calls that are being made on the code, how much CPU is it taking, how many calls, how much memory is being allocated or freed with the garbage collector for each of these things as deep as you want. So when you, especially when you're building for mobile devices or low power computers, this is something that you really want to look at constantly to make sure that you're not going crazy and to check your frame rates, right? Really useful tool. Much simpler version is here in this stats thing, which will tell you how many batches, that means how many different elements are in the scene, total triangles, total vertices, your frame time, 77.5, which is good, 100 actually. And yeah, the current set Pascal shadows caster, set Pascal is how many materials have been rendered. Saved by batching means like when you have two two items that are the same, it only renders it once, and then it can save a render call. So obviously the stuff that's moving, you cannot do that, but all the tennis fields are only probably rendered once because they're all the same. So it just like render these and then duplicate. So optimizing all of these is just, you know, takes time and it's necessary for all Unity projects once you want to do something slightly serious. But it's really easy to get something done in Unity really fast that you can see it working like this. It's really easy. Doing it right and for every platform, it's, you know, takes more time. Okay, let me show you like some quick videos now. Some other things that I thought would be easier to just look at in here. This is called Unity Automotive. It's a complete set of different tools thought specifically for basically like rendering and showcasing cars. And what you see here is this is obviously a video, but it's captured, it's real time. So this runs in real time in a normal computer. And you could therefore interact with it. You could put your head inside if you're in VR or something like that. So the automotive really looks at having like as much detail as you can in the scene because obviously like motor companies want to sell more. And this is like a move that Unity is doing more and more. And actually I went to talk to them when I was in San Francisco because they were interested in doing a science-based Unity at some point too. And they were gathering ideas. So this will happen more and more as Unity keeps growing. Like every year, there's like so many new stuff that you just cannot take hold of. And this is just one of the things. The quality is really insane. There's another one, another tool that's really interesting. If you are not good at Blender or 3ds Max or Maya and you need to build some stuff, there's this thing called Pro Builder, which is one of those packages that I showed you before that allows you to do some basic building structures in Unity. So beyond the classic primitives that you have, you can access this thing and just like slowly, more or less like you do in Blender, just move vertices up here and faces up there. Obviously, it's not a substitute at all, but you know, it can save you some pain in the ass if you are either, you know, I'm just gonna do this or hire a 3D artist and you can do it like this. Something really similar to this is it's called Polybrush, which is the equivalent of sculpting in Unity. Again, it's another package that you can download and use there. And you essentially do as you would sculpt in Blender or ZBrush. Same thing. And lastly, this is something that I haven't looked much into, but it's growing in popularity and more and more interesting. It's something called ECS or DOTS, which means data-oriented structures or programming or something like that. ECS is entity computing system, if I remember correctly, something like that. What it does is take advantage of the parallelism in modern processors. Because usually everything you did before, or everything you do, if you do normal Unity, you just like throw it into the CPU and the CPU decides what to do with it. With ECS, you can decide which core does what, and then you can do so much more, reducing the cost of these things. So check this out. This guy has like 100,000 of these little Lego guys running at 30 frames per second on a mobile device. This is freaking insane. This is impossible to do without ECS. Because it sort of distributes different renders into different cores. And because like nowadays, every processor has like many cores, you can do this kind of stuff. This is like really, really insane. You can see the frame rate up here. And yeah, that's it. If you have any questions or you want me to do something else, I can look into it. But that's all I had. Obviously, there's much more stuff, but maybe another day.
Yeah, maybe another day. What the fuck, man? That's amazing. Very good. And this Unity is a kind of like, I'm impressed. It's kind of like a porn for designers, no? You can do everything. I mean, it's super nice.
It's actually, you know, just specializing so much into different areas where you can have an expert in each area, and then you know each of them can have their own tools to work in it. So you have like an expert in Unity audio, you have an expert in Unity meshes and materials, VFX programming, and so on.
There's a similar approach as FreeCAD, no? Now it's divided in models, and you can install your models and you can, yeah, customize it in your needs.
Pretty much.
Yeah.
All right.
Anyway, thank you very much, Roger. It was amazing. It was amazing. Very nice.
No problem.
There's no other questions? No? Okay.
Well, if you have them, just shoot them to me, you know, yeah, my Telegram or email. So.
It was everything very nice. I think I will try with my partner to do something like a little game jam or something.
I mean, with your drawing, with your drawings, David, you could easily like create a game, like a 2D game, easily.
Yeah, because we use in a game jam, we try to use some more specific for 2D, that is Construct 2D. And it was very nice because everything was more think of you are going to make a platform of 2D and everything it was made for that. So maybe we try to do something, because when I tried long time ago the tutorials, I got out with some C# things that I think that I can copy better, especially with the float thing. The thing somewhere there is a float in there. And so I can keep those tutorials going out and try to make things a little better and everything.
All right, guys.
Okay, so Roger, thank you very much. Thanks for your time and your knowledge. See you this afternoon.
Yeah. Take care.
Okay. Bye.
Thank you.
Yeah.
Bye-bye.
I will stop the recording, okay, Santi?
Okay, dale.
Recording.